Welcome back. In this lesson, we're going to begin discussing graphing radical functions. So we've done with radical expressions. We've talked about solving radical equations. Now we're moving on to graphing radical functions. Now over here, you can see I've provided for you the parent function, all right? So we're going to graph these just like we've graphed almost everything throughout Algebra 2. We're going to graph it based on transformations. So first you need to know what the basic parent function looks like. Y equals square root of x. It looks like half of a tilted parabola. All right, so that's kind of the visual I want you having. It's half of a tilted parabola. Let's talk about how to take care of this. So let's start with a very basic one that's just a basic vertical translation. So you're always going to start with that parent function. Now, in this case, I provided the table for you. So the numbers you're going to use to begin with are always the same. You're going to be using 0, 0, because you know the square root of 0 is 0. You know the square root of 1 is 1. So there's your next value. The square root of 4 is 2. So that's your next value. And the square root of 9 is 3. So those are always your first points, all right? Just using the numbers you know how to take a square root of. And notice we are getting that tilted parabolic shape. And now, what are we going to do? Well, we're taking it 2 down. That's what our translation is telling us to do. So we take every one of those points that we just plotted and we move it 2 down, right? So this one moves 2 down, this one moves 2 down, this one moves 2 down, and this one moves 2 down. And when I connect them, I get something that looks like that. All right, so what transformation occurred here? Well, obviously just 2 down, or down 2, whichever way you prefer talking about it. Now, the more interesting conversation, talking about domain and range. So remember, domain is x values, range are the y values. So what x values are being used here? Well, for that, I'm always going to be using this point right here, okay? I always look to that starting point. What is the x of that starting point? Well, the x is 0, okay? And where are all my values going? Well, my values are increasing. So all my x's are above that 0. And what about the y values for the range? I use that same point, but this time the y values are down at -2. It starts down at -2, and then they're also increasing. I see everything rising, going up. So all my y values are greater than or equal to that -2. But you always want to start at that special first point, and then from there determine where are the x's and y's going. That's going to always be how we handle this situation. So let's move on to our next example. So here, horizontal translations. So once again, I'm going to start with my parent function. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So that's where I'm going to start, okay? Always start with that parent function. And now I'm going to see what translation happened. Well, here that's telling me I'm going left 4. Okay, so that's going to be my transformation. Left 4. So I take every one of those points and scoot them over 4. That one scoots over 4. That one scoots over 4. Scoot over 4. 1, 2, 3. Scoots over 4. And then I get that shape of a flipped over half parabola. Once I get that shape, now let's talk about the domain and range. So domain, this time my x value starts at -4. Okay, it got shifted to the left 4. And all the values are increasing. They're going up from that -4. So my x's are greater than or equal to that -4. My range, well, the y value of that point is 0. So I'm going to be comparing y to 0, and all of them are rising. They're above that point. So all my y's are greater than or equal to that 0. So let's keep moving forward. Let's talk about how we can combine transformations. Because that's going to be the ultimate goal here is, can we combine a bunch of these things happening together? Now, remember, this is the circumstance. Notice I have this vertical stretch now. Remember, that's the circumstance. I actually incorporate that into my table. That's the exception of where I don't just use those values straight off the table. I include a third column. Okay, so I take all of those numbers, all those square roots I found, and I incorporate the 3 in there. So I multiply every one of the, oh, I'm sorry, I've already messed that up. I multiply every one of these values by 3. Once I do that, now I don't really need that middle column anymore, because these are going to be the new y's of that parent function. I'm going to be plotting those points on the chart. So I have 0, 0. I have 1, 3. I have 4, 6. And I have 9, 9. All right, so that's my new stretched parent function, but it is very important that you put that in the table. Now, let's talk about what transformations are actually occurring here. So I'm going to scroll down so I have some room right here. So the transformation is obviously a vertical stretch of 3. Then what's happening? I see it being shifted to the left 2 and down 4. So recall now that shifting is what I do to every one of those points. Okay, left 2, down 4. So I'm going to start with this point. Left 2, down 4. Puts me right there. I do it to my second point. Left 2, down 4. Do it to this third point. Left 2, down 4. And this point up here at 9, 9. Left 2, down 4. Once I've done that, now I connect my points. And that is my new radical function. But again, the steps are put it in the table, put the stretch in the table, then shift each of them. All right, so let's talk about the domain and range. So I always start again at that special point right there. I start by comparing the x. That point has an x value of -2. And where is everything going? Everything's going towards the right. They're all increasing in value. So my graph, every x value is greater than or equal to that -2. What about the range? Well, what's the y value? Well, the y value is down at -4 of that special point. And where's everything going? I see every point on my graph going upward from it. So all of them are going to be greater than or equal to that -4. All right, let's go through another example of how this can present itself. So, -1/2 square root of x minus 3 plus 1. So, recall when I have this stretch out here, and in this case it's actually an x-axis reflection as well, But remember, when I have that, now I put that in my table. So I make a third column to my table where now I take all those values and I multiply them by negative 1/2. So this becomes 0. 1 times negative 1/2 is negative 1/2. 2 times negative 1/2 is a negative 1. 3 times negative 1/2 is a negative 3/2 or negative 1.5. I incorporate each of those into the table accordingly. So now let's talk about the transformations that are occurring. Well, obviously there's an x-axis reflection. That's what the negative means. There's a vertical compression, which is just a decrease in the stretch. Vertical compression of 1/2. We're going right 3 and up 1. That's what each of those pieces means. So now that we have our table, and remember, I can ignore these y's now. Let's plot some of these points. I have 0, 0. I have 1 and then negative 1/2. I have 4 and negative 1. Then I have 9 and negative 1.5. All right, so those are the points I have so far. Okay. Now let's shift them, because now recall I have to shift everything over to the right 3 and up 1. So I'm going to start with that first point at 0, 0. Right 3, up 1 would land it right there. The point at 1 and negative 1/2, I'm going to go to the right 3, up 1, which will put it right about there. That point at 4 and negative 1, I need to go to the right 3, up 1, would put it right there. And the other one is going to go off my graph, so I'm not going to be concerned with showing it because you won't be able to see it anyway. So that one, while the graph is a little bit difficult to see, just do realize it still has a curvature that it's supposed to, that is not actually a line, even though the way that we graphed it will probably kind of looks like it. So we have that now. Let's take a moment, let's take a step back and talk about the domain and range. Here's that special point, okay? The x value of that point is over at 3. I moved it to the right 3. And notice all of my x's are increasing, okay? So all my x values are to the right of it, meaning they're getting bigger, meaning it's greater than or equal to 3. My range, the y value of that special point, the y is sitting up at 1. Now this is the first time we've seen the things are actually decreasing. The y values are going down from that first point. So that means that every y value of my graph there is going to be less than or equal to that 1. Why might that be? Well, this is the first time we've had a negative. That flipped it upside down, so now the graph is decreasing, it's going downward. So it makes sense that my range is going to have all of its points decreasing. Every point is underneath that 1. All right, so we survived another day of graphing. So let's go down, let's talk about the summary. What should we talk about in our summary? Well, I never actually labeled out for you about domain and range. So I want you to describe to me how to find the domain and range. I think that'd be a really wonderful way. And then describe to me how you know to add to the table. Because sometimes we did, sometimes we didn't. So those are 2 little prompts for you about what you can put in your summary, with the things I'd like you to discuss in that summary. How to find domain and range, and then how do you know when you add value to the table versus when you just go straight to the graph. Those are a couple of things that you absolutely need to know, so I'd love to see that in your work. So come back with all the notes taken, those answered, and then make sure you're ready to come back and work on your practice work for me.